Hello, welcome to Algebra 1 with Miss Andrea. We're on a unit studying quadratic equations. And today we started with learning about how to factor expressions, and last lesson we started to get into solving expressions. We looked at when you have factored it, how you can then set it equal to 0 in order to solve it. Now remember what solving means. Solving means you're finding the zeros or the roots of an equation. That's how you find the solution. So if you had something like y equals 3x squared plus 2x minus 7, right? So if you had this quadratic equation, to find the zeros, essentially what that means is you're going to place a 0 there in place of the y. And do you recall or remember what it means when we put the 0 in place of the y? That's when we're solving to find the x-intercept, right? So if we took and graphed this quadratic equation, it's going to look like a parabola. Remember, when you have y equals x squared, the parabola will look something like this. And this has one solution, the solution of 0, 0. So the root is 0, or the 0 is 0, or the solution is 0. And there's only one solution, x equals 0. But you can alter this equation. If this is your standard equation, you can alter it to make something like we have over here, 3x squared plus 2x minus 7. And that graph might look something like this, where we have two solutions. So in this case, you'd have an x equals and an x equals, and you'd have two numbers right there. Another possibility is if you had a graph that's all the way up here, a parabola, in which it never crosses the x-axis. So in that case, you'd have no solutions, or there'd be no zeros or no roots, okay? So today we're going to get into, the last one was when we would factor something out and set it equal to 0. So you can see why it's called finding the zeros, right? Because when we had a times b equals 0, that told us that either a equaled 0 or b equaled 0 or both, right? And or. But today we're going to find out why it's called the roots, finding the roots, okay? So we're going to solve by square root. You guessed it. That's why it's called finding the roots. So using this method, what you have to do is you're going to have to get whatever is being squared by itself, and then you take the square root. Okay, so in this case, we have x squared, and we just need to get it by itself. So in order to get it by itself, I'm going to have to move this plus 5 to the other side. So x squared, well, it's a minus 5, but when I move it to the other side, if it changes sides, it's going to change signs and become a plus 5. So 27 plus 5. So that's going to be x squared is 32. So one thing that's going to be helpful here is to make sure you have a calculator that can do square roots, right? You want to make sure you have that. But not every square root is going to have a perfect square. So the square root of 32, well, before I get to that, let's say why we're going to find the square root of 32, because this is x squared. And remember, we need to find x by itself. And so x is not by itself right now. X is being multiplied by x to figure out what 32 is. So the only way to undo this squared right here is we have to square root it. A square root cancels out a square, just like division cancels out multiplication, addition cancels out subtraction, things like that. So we have a square root undoing the square. So whatever you do to one side, you must do to both sides. So you have to do a square root to the right side as well. Now, I can't remember if this is something we covered or not in Algebra 1, but one thing you need to know with square roots is that if you introduce the square root to a problem, you must put a plus or a minus in front of it. So since I introduced that square root symbol, I have to put a plus or a minus in front of it. So if you have something like 3 plus the square root of 2 minus 5, you don't have to do that because this square root of 2 is positive because what's in front of it is only a plus, okay? It's only when you introduce, you're the one adding in the square root that you have to have both the plus and the minus. And the reason why is if you want to find, say, the square root of 4, if you have x squared equals 4, and you wanted to figure out, well, what's x? And you did the square root of it, okay? Well, that's going to leave x on this side because this will cancel out. And we generally think we know the answer to square root of 4, and the calculator only gives us one answer to the square root of 4. It tells us it's 2. But in reality, there's another answer. It's the positive 2 or the negative 2. Because if you think about it, negative 2 times negative 2 is going to be what? It's going to be 4, positive 4. Because two negatives, an even amount of negatives when multiplied, gives us a positive answer, and 2 times 2 is 4. So the square root of 4 is either a positive 2 or a negative 2. So there's actually two answers hidden in there. So when you introduce the square root symbol, you have to make sure to include the plus or the minus sign. Include both answers, right? So we have here, we've taken care of the square root of x squared. That is just x. Now the square root of 32, I told you it wasn't going to be a valid number when I plugged it into my calculator. I got 5.656854249. And it goes on past there, but that's what my calculator rounds it to. Now, this is, remember, what we call an irrational number. It's a number in which the decimal point will never end and never repeat. So this is an irrational number. So if we want to find an actual exact answer, we can't just plug this into our calculator. We're going to have to take 32 and factor it out, right? So we're looking for anything, if when we simplify the square root of 32, we're going to simplify that. So 32, I know that it's going to be divided by 2. Okay, so I'm going to start with that symbol there. So that's 16 divided by 2. That's 8 divided by 2. That's 4 divided by 2 again is going to be, so 1, 2, 3, 4, 5. There's 5 2's there, right? Double check that. 1, 2, 3, 4, 5 is 32. Okay. So 32 completely factored is what we have here. Now what you have to do is you have to pair up any factors that are the same. Okay. Now these paired factors, they're going to get married. And when two factors get married, they become one and they move out of their parents' house. So when I taught in-person classes, a lot of students called this radical sign or the square root sign a house. So we're going to say that these two 2's, they're going to get married. They're going to become one and they're going to move out of the house. So we've got the square root of 32 is going to equal these two 2's got married, became one, moved out of the house. These ones, that pair also got married, became one, and moved out of the house. And then my lonely only, this number 2 right here, is still living inside his parents' house. Okay, so the square root of 32 is the same thing as 2 times the square root of 2. Okay, and you can see that because 2 times 2 is 4, and 2 times 2 is 4. And to get rid of the square root sign, I can find the square root of 4 is 2, and the square root of 4 is 2. So you can see how that rule works. But when you find the factored form of 32, you can pair up things, have them get married, and move out of the house. And that's how you can simplify your square root. So the square root of 32 is 4 square root of 2. And that's your final answer here. Don't forget to have your plus or minus. We didn't do that here. So x is positive 4. I don't need to write a positive. Let me erase that. x is positive 4 square root of 2, and x is negative 4 square root of 2. Those are my two answers, two solutions, two roots, or two zeros to the equation x squared minus 5 equals 27. All right, so let's try that again. This one just had x squared, but what if you have something like x minus 2 squared? So this looks a little different already from the get-go because it's not just x that's being squared. So do we treat this any differently? Well, not to start with, because remember our first step was to get the item that's being squared by itself. So what does that mean? I need to get x minus 2 squared by itself. I have to get rid of this -1 and move it from the left to the right. And when it switches sides, it's going to switch signs. So I'm going to have x minus 2 equals 7 plus 1 because it's switching sides. So that's just going to be 8. Okay. That's squared. I can't forget to write that. Now to undo this squared symbol, what I have to do is square root both sides. So x minus 2 equals plus or minus the square root of 8. So now I need to figure out what is the simplified version of the square root of 8. Well, I know that 8 is 2 times 2 times 2, right? And I have one pair in there. So the square root of 8 is going to be 2 because they're going to get married. 2 will become 1 and move out of the house. My lonely only will still be in the house there. So x minus 2, I'm now going to have two answers to work on. X minus 2 is 2 square root of 8, and x minus 2 is negative 2 square root, oops, I said 8. Oops. It's not 2 square root of 8. It was 2 square root of 2. Square root of 2 there. Okay. So you see I have my positive answer and my negative answer because when I inserted that square root symbol, I have to have both a positive and a negative answer here. Now, to get now in order to solve, I have to get x by itself, which what's happening right now to the x, it's having a minus 2, a 2 subtracted from it. So in order to undo that, I have to add 2. So I'm going to have x is 2 square root of 2 minus 2. And then on this side, I'm going to have not minus 2, plus 2. X is negative 2 square root of 2 plus 2. Now, usually I think that the format for square roots or for radicals, which is the name of the square root symbol, that's called a radical, is that they're going to go after the constants. So the best way to write this would be x is 2 plus 2 square root of 2. So I've taken this term and moved it to the right, and it was positive, so that didn't change. And this term and moved it over here, and it's positive, so that didn't change. So you can do that kind of moving around. If you move things around on the same side, you have to make sure they keep their same sign, right? So in this case, if I want to get the constant first, it's a positive 2, so I'm writing positive 2. And then I want this term with the radical to be next. So I'm going to put it negative 2 square root of 2. Now, why can't I combine or simplify these terms and reduce them down into one term? Well, that's because we have the radical 2. If you remember from when we studied radicals, you can only simplify or combine down the radicals when they're being added if the radicals are the same. So in this case, we have a radical 2, and in this case, we don't have a radical at all. So it's the same as if I were to say 2 minus 2x. Could I combine those? No, I couldn't, because one is a constant and one has the variable of x. So anytime you see a radical and you're thinking about combining like terms, treat them like variables. If it's not exactly the same with an addition or a subtraction, you cannot combine them, okay? So our two answers for this equation is x equals 2 plus 2 square root of 2 and x equals 2 minus square root of 2. Now, both of these answers that we've gone through so far are what we call the exact answer. Okay, because this is exactly what it is, because it has an irrational number in it. So you have to put the irrational symbol, the radical symbol, to make sure we know exactly what the answer is. But sometimes you're asked to find an approximate. Find the approximate answer or approximate solution to the problem. Okay. And when you do that, all you have to do is plug the answer into your calculator. So I'm going to put 4 radical 2 and hit enter. And remember, I've already done that, 5.6, whatever. So my approximate answer is x equals 5.7. I'm just going to round to the 10th place. And it's actually not supposed to be an equals. It's the wavy symbols, wavy little equal sign. That means approximately or roundabout, kinda. It's kinda this. It's mostly this, negative 5.7. So those are my 2 approximate answers. So what would my approximate answers be here? Well, I'd say x is roundabout or kinda 2 plus 2 radical 2, and I hit enter and I get 4.82, which rounds to 4.8. And then this one is going to be 2 minus 2 radical 2, which is negative 0.8. So my approximate answers are x is about 4.8 or x is about negative 0.8. Now, one thing you notice in these equations is that there's only one term that has a variable. There's one term with a variable here and one term with a variable. So when you solve by square root, it's not going to be you're not going to be able to do it if it's something like we started with 3x squared plus 7x minus 2 equals 0. This one won't work because you not only have the x squared, but you also have the x. Okay, so you have to make sure when you look at an equation, if you see that it only has one term with a variable in it, then you know that might be one I can solve by square root, by finding the square. All right, I think, yeah, this is the page we're on. I hadn't switched it yet. So let's look at these. Again, we want to get this term by itself, so I have to undo everything that's being done. And remember, we have, not FOIL, PEMDAS. When you're doing the math, you go down. When you're undoing the math or trying to figure out what the hidden value is, or doing algebra or solving for a variable, you're going to move up. So we need to undo. This is to undo things. So we need to undo the addition and subtraction first. So when I look at this expression here, what do I see being added or subtracted? I see the minus 3 being added or subtracted. So I need to undo that one first. So I'm going to have 2x plus 1 squared. I'm not going to do anything with that. And then my minus 3 is on the left, and I want to get it to the right. And if I switch sides, I need to switch signs. So it's going to become a plus 3. So 7 plus 3, 7, 8, 9, 10. I'm just going to write that as 10. All right, so now what we need to do is we did our addition and subtraction. Now we need to undo some multiplication and division. So the 2 is being multiplied by this stuff that's inside some parentheses being raised to an exponent, right? So I'm going to undo the 2. All right, so I'm going to divide by 2 on both sides. And I have x plus 1 squared equals 5. All right, so continuing up, climbing up the ladder of PEMDAS, my next one is exponents. I need to undo the exponents, and that will naturally remove my parentheses. So if I undo my exponent, I have to have a square root to undo my square. And if I do it to one side, I've got to do it to the other. Remember to write my plus or minus here. So I'm going to have x plus 1 is plus or minus square root of 5. Now, I have another expression. So what do? I'm going to go back up my PEMDAS. I'm going to climb back up the ladder, starting back at the bottom, because my parentheses that I used to have that were untouchable because they're at the very top. Now that the parentheses are removed, I'm going to start undoing that from the bottom again. So we've got addition and subtraction here. X plus 1, I need to undo this plus 1 by subtracting it. So x equals plus or minus square root of 5 minus 1. Now let's get this radical second, and I can go ahead and break this up into my two answers. X equals -1 plus radical 5, and x equals 1. Oops, -1 minus radical 5. So those are my two answers. You see I have -1, and then I did plus radical 5 and minus radical 5. Radical 5 is already in its simplest form. So these are my exact answers right here. Now, if I wanted to find the approximate answers, I'd plug those into my calculator. And it seems as if in this curriculum, they don't tell you what to round to, but you can just round to the 10th. That seems to be what they do in the module. So that's what I would recommend you to continue with. All right, so let's look at this one. 5x plus 2 squared minus 3 equals 4. Moving up the PEMDAS, we have to undo the addition and subtraction first. So we're going to add 3 to both sides. So I've got 5x plus 2 squared equals, what's 42 plus 3? It's going to be 45. Now we're going to divide by 5, and I'm going to have x plus 2 squared is 45 divided by 5 is 9. And let's just double check that just to make sure, because I have a calculator, I should use it. I did 45 divided by 9 in my calculator. Let me do that again. 45 divided by 5 is 9. We should always use a calculator when it's available to us to confirm even simple problems. I probably should have done it on 10 divided by 2 and things like that. I generally use it anytime it's going to be anything over a 2 or 3 or just something that's so familiar to us, because I know that the majority of mistakes made in math are simple mistakes that can be caught by using a calculator. So I suggest using a calculator at almost for every problem. All right, so now to undo this square, we have to square root it, and the square root undoes the square. We have x plus 2 left, and since we did that to the left side, we also need to do it to the right side. So here we're going to do a square root of 9. Now the square root of 9, I happen to know, is 3, but let me just verify that. Square root of 9 is 3. That's correct. Now again, my calculator only gave me the positive answer. And so I need to remember that it's actually a positive or a negative because I inserted that square root there. So now I can break this into, well, we can leave it just like that for now. And I'm going to do x plus 2 is, I want to move that plus 2 from the left side to the right side. So if I want to switch sides, I need to switch signs. So I've got a plus or minus 3 here, and my 2 is moving from the left to the right. So it's going to change positive to -2. Now I want to rewrite this with my -2 first, and then I want to break this up into 2 problems. So I'm going to have -2 plus 3, and I'm going to have -2 minus 3. Oh, and are we done? No. Whereas remember, this one we were done because we had the radical. This one, because there's no radical, we can actually do it. So I didn't even need to reorder it. I could have just done 3 minus 2 and -3 minus 2. So I suggest, again, because these are negatives, definitely use your calculator, okay? -2 plus 3 is going to be 1, and -2 and -3 is -5. So x equals 1 and x equals -5. There is no approximate answer for this one because we have all real numbers. Only exact answers for this problem. All right, so I've got a problem here that I want to show 2 different ways. This one's going to be taking the square, and this one's going to be by factoring. which is what we learned before. We learned how to solve through factoring or finding the zeros, setting the factors equal to 0. And so we're going to do that with this problem after we solve by taking the square. And we're going to see that sometimes you can do both ways, multiple ways to solve the equation. And we're even going to learn more ways in the next lesson. So you need to see which way works best for you, which way you like best. But also not every way works for every problem. Like we said, if there were another term in here with just a single x, you couldn't do taking the square. So you have to know how to do all of these methods in order to be able to solve every question. All right, so taking the square, we have here 16x squared minus 81 equals 0. We want to get this squared term by itself. So climbing up the ladder of PEMDAS, we're going to undo this subtraction first. So we're going to have 16x squared equals 81. I added 81 to both sides, or as it switched sides, it switched signs. All right, so now we need to undo the multiplication that's being done, 16 times x squared, and we're going to be left with x squared equals 81 divided by 16. 81 divided by 16 is a decimal. So we're going to have 81 over 16. Let's keep it like that because we want exact answers. Now, in order to undo the square root, remember what we do is, or undo the square, we do the square root, okay? And if you remember back to the lesson about square roots, when you take the square root of the whole thing, that's the same thing as taking the square root of the numerator and taking the square root of the denominator. So our x is going to equal, what's the square root of 81? Well, it's plus or minus 9. What's the square root of 16? It's plus or minus 4. So my two answers are x is 9/4 and x is negative 9/4. So those are my two exact answers. That's taking the square. Now with factoring, I'm looking at this and both of these are perfect squares. So remember 16 can be broken up to 4 times 4 times x times x. 81 can be broken up to 9 times 9. And I've got my minus sign in the middle. So I can solve this through factoring using difference of squares, which when I set this up, I know I have to have two sets of parentheses, one with a plus sign in the middle, one with a minus sign in the middle. I'm going to take the root of my first term and the root of my second term and plug the. I'm going to set each one of these equal to 0 because either one could be equal to 0 and be correct. So 4x plus 9 equals 0. In order to solve, subtract 9 and then divide by 4. So I get negative 9/4. On this one, I'm going to add 9 and then divide by 4. So I'm going to get positive 9/4. And as you can see, using factoring, I got the same answer as I did taking the square root. So you can do whichever way easiest for you, preferred method when you have a quadratic equation that can be solved in multiple ways. And like I said before, not all of them can. All right, so here is some practice problems for you. I want you to pause the video and work them out on your own. Welcome back. All right, so we want to get x squared by itself. So we're going to subtract 24 from both sides. So I'm going to be left with 3x squared equals negative 24. Then I need to divide by negative 3 on both sides. And I'm going to be left with x squared equals 8. A negative divided by a negative is going to result in a positive because there's an even number of negatives. For multiplication or division, we have a positive answer. And 24 divided by 3 is 8. So now to undo this square, we have to find the square root. So x equals, I introduce the square root, so it must be plus or minus the square root of 8. Well, the square root of 8 is going to be an irrational number, but I can reduce this because the square root of 8 is the square root of 2 times 2 times 2. And there's some people getting married. They're going to the altar. 2 are becoming 1. So it's going to be 2 square root of 2, my lonely only. These 2 become 1, move out of the house. This lonely stay right there in the house. So my x equals a positive or minus 2 squared root of 2. And you could write that as, you're supposed to write it as 2 separate answers, but since we're kind of limited on space, I'm going to leave it like that. All right, so this one we're going to have x minus 3 squared equals a positive 49, because as it moves from the left to the right, if it switches sides, it's going to switch signs. So from the left, it's a negative 49. So on the right, it's going to be a positive 49. And then we're going to take the square root of both sides. Square root. So I'm going to be left with x minus 3 equals 7. Square root of 49 is 7. Let me just double check that. It's correct. X minus 3, I want to add 3 to both sides. So x equals 7 plus 3 is 10. So do I have 2 answers with this equation? Well, if you noticed, I didn't find 2 answers, but should I have found 2 answers? I should have, because the square root of 49 is not just 7. The square root of 49 is also negative 7. Okay, so it's easy to not remember to put your positive and your negative in. You have to always go back and just double check over your work anytime you have a quiz or test, and make sure when you've inserted a square root, you've gotten both a positive and a negative answer, okay? So now I'm going to add 3 to this. So negative 7 plus 3 is going to be negative 4. So x is negative 4. So my 2 answers in this case are going to be x equals 10 and x equals negative 4. And so here we're going to have, oh, there's nothing for me to add or subtract. So I'm going to start with the multiplication in this one. So, or undoing the multiplication rather. 2 is being multiplied by this, so we have to divide. So it's going to be, I'm going to be left with x plus 1 squared is 64, divided by 2 is going to be 32. Half of 6 is 3, half of 4 is 2, so it's 32. And you should verify that in your calculator. Now x plus 1 squared, in order to undo that, we're going to cancel those out. And then we have to undo this side as well. That's going to leave me, remember, with how many answers? 2 plus or minus the square root of 32. And the square root of 32 is, if I remember correctly, 2 times 2 times 2 times 2 times 2. All right, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's correct. 1, 2 pairs. So x plus 1 is plus or minus 4, the square root of 2. This 2 came out of the house, became a single 2. This one came out as well, became a single 2. And then inside the house is still the 2. Now, you can also do this if you want a little faster method. You can say, well, 32 is the same thing as what? 16 times 2. Okay, well, that breaks up into square root of 16 and square root of 2. Well, that's 4 square root of 2. So you can get there both ways, but if you're having a hard time seeing what perfect squares are factors of this number, then you just want to go ahead and do some complete factorization and match up those pairs. Marry them, get them, kick them out of the house, get them married off. All right, so here we have 3x. Oh, this is my final, not my final answer, because it says x plus 1, right? So I still have to subtract 1 from both sides. So my final answers are going to be x equals my subtract 1 plus 4 square root of 2. And then my other answer is my subtract 1 minus 4 square root of 2. These are my 2 exact answers, and that's the proper way to write it instead of with this plus or minus. All right, so 3x squared minus 81 equals 0. Undo this subtraction first. We're going to be left with 3x squared equals a positive 81 because it moved from the left to the right. So it changed from negative to positive. 3x squared, we're going to divide by 3. 81 divided by 3 is 27. X squared equals 27. Okay, now let's take the square roots. Square root, x equals plus or minus the square root of 27. Now, I know that 27 is 9 times 3. And I'm going to verify that real quick on my calculator. 9 times 3 is 27. And so 9 times 3 being 27, I know that 9 is a perfect square. So the square root of 27 equals the square root of 9 times the square root of 3, okay? Which is going to equal, what's the square root of 9? 3, square root of 3. Okay, so x equals 3, square root of 3, and x equals negative, because that's my positive and that's my negative, 3, square root of 3. And those are my two answers.